Today we're going to be looking at Curl Up and Read, which is a hard web challenge from San Diego CTF 2022. Because this challenge is hard, we can expect some domain-specific knowledge about web servers to be required, as well as a certain amount of creativity, but I think this challenge does a decent job at nudging the player towards the solution in small steps. The prompt reads, "This app will show you the reader view of any website you visit. No more ads, cookie nags, and paywalls, just content." Sounds pretty good to me. And then it provides a link to the challenge. This challenge also provides a copy of some of the source code of the web server. It's written in Next.js, which is a JavaScript full-stack framework, but we're going to read this later. For now, let's just look at the website in question. We can see that the landing page for this is very bare bones. All we have is a single input field and a submit button. We can try to use this website as advertised by feeding it a URL to a web page we would like to read. For demonstration purposes, I have elected Mr. J. Kenji Lopez Alt's butterflied roast chicken recipe. If we enter the URL into this field and hit View Reader Mode, we will be redirected to another page, and soon a pretty convincing reader view of the website is rendered for us. Let's take a closer look at the URL we were redirected to. This seemingly random string after the read route looks to my eye to be base64 encoded. I can verify this theory using the favorite CTF companion tool CyberChef. This string seems to be a base64 encoding of a JSON payload that only contains the URL property with the URL we entered. Therefore, we may be able to change this payload to something that benefits us. I think at this point we have enough context to look at the source code of the web app. This export default function is responsible for what is shown to us when we load this web page. We can see that the readability view is rendered with the strictest possible sandboxing, so it is unlikely that we will be able to pull off a cross-site scripting bug by rendering a web page of our choosing. It's also not obvious how we would weaponize such a vulnerability in this context. This content variable is computed in the get server-sided props function down here. We can see that the base64 encoded parameter provided when loading this page is processed through a gauntlet of checks and validations. First, it validates that the input is a string. Then it base64 decodes the string, and if that fails, we get a 404 response. Then the decoded string is JSON parsed. If that fails, the page gets a 404 response. Then the string is validated against a schema, which is at the top of the file, that describes explicitly the properties that are allowed to be in this JSON object and what those properties should look like. If all of those checks are passed, we can see that the URL provided is downloaded using curl, which is an odd choice, and the downloaded URL is then passed through some libraries that generate the readability view. We also get these handy comments that let us know that this rendering process does not execute JavaScript, which does narrow our search for vulnerabilities quite a bit. Provided that the readability successfully parses the document, then the view is rendered. The only part of this code where the flag is even mentioned is right here, in the process options that are used to execute curl. We can see that the environment variable called flag is explicitly set to redacted, with the comment, "Even if curl is somehow pwned, it won't have access to the flag." I think this is supposed to be a hint that the flag is stored in the environment variable called flag, and so the goal of this challenge then is to read the value of that environment variable. This also gives us the hint that the author of this code is worried about curl being pwned somehow, and considering that curl is the name of the challenge, there's a good chance that the unconventional use of curl in this routine is going to be a part of our exploit. When you see that a command line program is being executed here, you might be tempted to think of command injection. This is where you can enter shell control characters to execute additional commands aside from the one that was intended. This is especially compelling because we, the attacker, can control this URL parameter. Unfortunately, the API being used to execute curl here is execfile, which executes a program without invoking the shell. If plain old exec was being used instead, this does parse arguments similar to how a shell would, so we might be able to take advantage of that. As it is, though, we can only control this single parameter to curl. Even if we put a bunch of spaces or other wild control characters into this variable, it would still be passed to curl as a single parameter. Okay, So we can only control this one parameter, the URL that curl downloads. Is there any way to convince curl to return an environment variable? Well, we can read the docs for curl at least and get a good idea of what it can do. As it turns out, it's quite the Swiss Army knife. If we scroll down to the protocols section, we can see some descriptions of the various things that can be downloaded, including some definitions from online dictionaries. I've never used any of these, but the second one is interesting. It says we can download local files with this file : / syntax. I've never seen this before in my life, but it looks promising. It could end up being a type of local file inclusion vulnerability. In fact, on the Hacktricks page for this topic, it even mentions this protocol explicitly. If we do file : / it doesn't seem to work. It says that our URL format is invalid. As it turns out, we need to include the additional leading slash of the absolute file path for a total of 3 slashes. And just like that, it reads whatever file we give it. Very cool. Well, let's try this out then. If we enter this file path into the reader view input, we get nothing. Okay, it looks like there might be a client-side check that's preventing us from submitting this, but that's fine, right? We can still bypass that fairly easily and submit this request directly to the server. Only, now that I think about it, we actually do know for a fact that the server is validating the submitted payload against the URL format. So I don't really see how we have any flexibility here to give it a file path. Well, actually, hold on. It's validating against the URI format. What exactly is a valid URI? Is it different than a URL? Well, if we look at the JSON schema specification, we can see that this is any string adhering to RFC 3986, which is great because that number means absolutely nothing to me. Although now that I think about it, I think I recognize that RFC from the man page of curl. This should be the same set of protocols that curl understands. So actually, this might be a bug. The author of this web page is probably intending to filter out anything that isn't an HTTP URL, and they appear to be doing just that on the front end. But on the back end, they're only filtering for URIs, which includes this local file path, provided that we include that file : / prefix. Let's try sending this by encoding the payload in CyberChef. We'll put our JSON payload into the input, and we'll change the URL to, say, Etsy password, and we'll encode this to base64. Then we could just attach this to the end of the read route, and wow, okay, that actually worked. Okay, so we definitely have a local file inclusion bug. The question remains, is there any way to turn this into a way to read environment variables? If we look at the Hacktricks page for Linux environment variables, we can actually see some examples using the virtual /proc file system. Let's assume, perhaps correctly, that we don't really understand how this /proc file system works. Let's visit the documentation for /proc and just search for environment variables. We find that if we manage to type /proc/ the process ID we're looking for /environ, that should print the environment variables passed to that process. The problem is that we don't know the ID of the process we're interested in. We could brute force it, at least in principle, but I actually know a neat trick that will help us out. Rather than using a process ID, if we instead use proc/self, this will return the environment variables for the currently running process. We can do this on the CTF web server, jumping through the hoops of encoding this payload with CyberChef before passing it along, but all we get in return are the environment variables of the curl process, and the variable for flag is, of course, redacted. This is because these are the environment variables for the curl process and not the web server. How then are we supposed to get the process ID of the Node web server so that we can look at its environment variables? While the curl process has its own process ID, it's also true that it should have a parent process ID, and that ID should be the process ID of the web server. So if we can find a way to print the parent process ID of curl, that should be what we're looking for. Back on the documentation for /proc, we can actually see that the /status path does return that information under the field PPID. So this should allow us to execute a two-stage exploit. Stage 1 is to encode the /proc/self/status to our base64 string, and then pass this to the web server to get, among other things, the parent process ID of curl. Once we have this parent process ID, we can go back to CyberChef and encode a new payload containing the path /proc, the parent ID, /environ. And if we pass this new payload to the web server, this should give us the environment variables of the server, including the unredacted flag variable, which indeed contains the flag that we were looking for.